what is harder for you, answering some of your students' hard questions or answering some of your daughter's hard questions?
Ooh. um, you know, the hardest questions always come from people who know the least
Mm,
about the subject. My kids and I talk a lot about science, but when you ask me that question, where my mind goes is to my students who are not physics majors. I teach this course frequently. It's called Astronomy 100. It's for, musicians and business majors and people who think that they're not scientists. And it's always the most unassuming student raising their hand and
yeah.
going like, what is inside the black hole? Okay, so this is a question that's really easy to answer to a graduate student studying physics. Well, singularity, right? And I'm done. I'm just done. Yeah.
Yeah.
Then comes the follow-up for my Astro 100 student. And what is a singularity?
Mm-hmm.
Okay, this is where you start to sweat a little bit.
Mm-hmm.
That's the point at which, the laws of general relativity in physics as we understand it really don't apply anymore. What does that mean?
Mm-hmm.
What does it mean? Right? And this is typically where I have to be like, you know what? I have to think about this.
Mm-hmm.
I have to think really hard and bring in everything I know, my entire physics experience, to really answer this question. And I ought to be able to do that.
Mm-hmm. Yeah.
Right? And this is also where you realize that what we consider knowledge isn't just the equations that are going to make a prediction. We really feel like we've understood the universe when we can come up with these natural human language narratives of what's actually really happening. And math is not the only language of science. It's one of them. It's a necessary one. It's incredibly powerful, but it's not enough.
Mm-hmm.
And I think as a community, my hope is that we lean more into valuing our ability to communicate and share, truly share these stories of our universe when we understand them and make an effort to share them with people who do not speak math.
Mm-hmm. Yeah. Yeah. Have you found that degree to which you teach undergraduates and graduate students, you find yourself being a learner as well beyond what you're studying with your research?
Absolutely. Yeah. I think it's hard to imagine this profession for me personally as something I would do in isolation without other people. I think we've leaned for a really long time into this narrative of lone geniuses,
Yeah.
right? People who will make breakthroughs and then impart them on the world. But I don't think this is really how science works. I don't think this is what drives science now, even. I mean, look at Rubin, right? This is this huge collaboration of so many people. Not all of them are lone geniuses. Maybe none of them are geniuses. They're smart people, they're driven. But what they're accomplishing is by working together, by bringing their different perspectives and their different expertise together with this common goal. And to do that, you have to be able to talk. You have to be able to exchange ideas. You have to be able to operate in this space of community. It's an inherently human endeavor. It's an inherently shared endeavor. If I figure something out and die with the knowledge, I haven't changed the world.
Yeah.
I mean, it might feel good, but the mission isn't accomplished really at that point in time.
Yeah.
And moreover, I do think that when I take the most joy out of my science, there's that moment when I sit down with my kids and tell them the story of neutrino particles that don't really like to talk to other particles very much. So they travel billions of light years through space before ever bumping into anything. And as they travel, they get to ruffle up the galaxies in ways we can see through our telescopes. And they can understand this story. And this story is naive and goofy and childlike, and I should be ashamed, to tell it this way as a serious scientist, or that's at least the sense of the way our communities work. And yet it's also, in a sense, very true.
Mm-hmm.